So now we're going to move on to question 12, which is the last question that has to do with a logistic function. So a logistic function that we're dealing with is 500 over 1 plus 450 e to the negative 0.7x. Okay. Now the first thing you need to know about a logistic function is a logistic function looks like an S curve. So it goes up and it does that. That's if it's increasing. So that would be, this would be, for example, a rumor population growth would look like that. And then it would be decreasing if it was the value of a cell phone or something like that, or car value could decrease according to logistic model. Now, this particular logistic model is an increasing logistic model because it's a spread of a disease. So it's going to look like this. Now, what the logistic function does, it has an upper limiting value. So over time, it goes to a limiting value, so it doesn't get any bigger than a certain value. And that certain value it doesn't get any bigger than is that top one right there. So if you look at part B on the practice test, it says what's the maximum number of people that could be infected by the virus, and that would be this number in the numerator, so 500 people. And that makes sense because once everyone in the group is infected, no one else can get infected, so it's going to limit to that. All right, part A is the one that requires a little bit of calculation. So part A says how many students had the disease when it was discovered on day 1. So you should plug in 1 for x because x is the number of days. All right, so we're going to plug in 1. So we do 500 over 1 plus 450 e to the negative 0.7 times 1. And we key that into our calculator. So I'm going to key that into my calculator. So I suggest that you key it into your calculator as well. Be careful with parentheses when you're doing this. And if you don't get the right answer, it's probably because of that. And I get 2.22753. And it asks us to round to the nearest whole number, so that would be 2 people. There we go. So that's fairly easy, isn't it? So logistic functions are very good population models.